Today it is time to talk about the future of our forest operation. We are launching our Strategic PCI Increase Initiative, a project designed to to increase our performances by aggressively targeting an, we can say, a increase or a sort of a incremental 15 kg per ton hot metal coal injection. And this is not just about adding coal, it's about engineering our ways to cost leadership through the precise optimization of our reducing agent rate. So let's look at our primary goals. Now, coming to the driving cost, uh, um, that is driving cost leadership and thermal stability, about which we will talk a few important points. Our primary objective is a win-win for plant. We are driving down high cost coke rate while simultaneously improving energy efficiency in the raceway. So by utilizing CO2 enrichment, number one, and we are not just increasing the volume, we are enhancing productivity also while maintaining the delicate thermal stability of the furnace. So to hit these 15 kg per ton hot metal target, we have identified four technical pillars. The four identified four technical pillars that will serve as our foundation, and this four will be the key, and routing these four will help in increasing our injection rates, and which will finally accomplish the rise in PCI coal level. Now, what are those four core technical pillars that is to be shared? So, uh, mm, uh, we must address the entire iron making value chain while addressing these four pillars, and which is important to address this value chain. So our roadmap focus on PCI plant preparation for rapid devolatilization, elevating Coke CSR to protect the dead man, and dynamic flame control, and optimizing burden distribution to safeguard gas permeability. It all start at beginning of the chain with our infrastructure. So the key improvement area that we have discussed so far is basically a PCI plant preparation. Here all delicacies that we have to see, that whether compatible granulometry is getting prepared or not, with the residual moistures. Those are one of the most important part. At the same time, we also need to see that smooth running of the PCA plant, because many times interruptions do also have a lot of ill impact on the injection potential. Second is the Coke CSR, which is we cannot deny that this Coke CSR is one of the very important foundation for enhancing this target what we have thought of, or which we have committed to the company for increase in PCI around 15 kg quantum, and as we know, the increase in PCI coal has got a cooling effect. So, in order to combat this cooling effect, we need to increase our RAFT also. But at the same time, we need to also see that this RAFT is not going on an adverse boundary. So once we met this RAFT control, our things are more than 90% done technically. So, and next is the burden distribution, suppose, and which is a such a backing segment or backing activity which can help each part of the activity to and to enhance this coal injection part. So now coming to the infrastructure and precision grinding, about which consistency our mantra for the PCA plant. To support this higher rate, we are targeting a grinding consistency where 80% of the particles are less than 74 micron, and this ultra fine sizing is critical for instantaneous combustion. So furthermore, we must maintain an exit moisture of less than 1% to prevent the nightmare of lens plugging and ensure a plus minus 2% accuracy in tier-wise distribution also. So once it's in the furnace, we have to manage the heat, and at the same time we need to also see the equipments like any foreign item in the grinding mills, especially the back filters burn out small particles clogging the lances. These are to be avoided in order to have a consistency, a stability of a coal plant. Now coming to the raceway optimization, that is mastering the flame, mastering the raft, we can say. The heartbeat of the furnace is the raceway, as we can rephrase in a number of ways. As we ramp up the injection, we must maintain our theoretical flame temperature at 2150 plus minus 50 degrees centigrade. So we achieve this through precise increase in oxygen enrichment, and this ensure that we are maximizing the kinetic energy of the blast to facilitate the high speed coal gasification, which is very much required. And this thermal balance is the key to what happened next in the stack. So coming to that part where lower stack efficiency and maximizing carbon monoxide generation are important activity. So by optimizing the raceway, we are essentially turning the furnace into high efficiency gasifier. So maximizing carbon monoxide generation at tier also ensure the efficient reduction of iron oxide in the lower stack also. So this chemical efficiency is what allow us to push the furnace harder while keeping the process smooth and stable. However, as the coal goes up, the Coke skeleton must remain strong, and for which we have seen all about eco quality imperatives, and this is not negotiable at all. If we talk to anyone of from blast furnace, they will say these are the not negotiable things. So as we increase the PCI, the coke layer naturally thin, and to compensate, we are elevating our quality target to ensure the furnace has a strong mechanical skeleton. So we are targeting a good CSR, coke strength after reaction, of around 65 plus for a bigger furnaces, and even go up to 67, and micam 40 of more than 85%. So all while keeping ash level below 10.5%. So why this strength is so vital? So let's look at the raceway boundaries. So once we come across the raceway boundaries, it prevent the bird nest and maintain the permeability. So higher CSR is our primary defense against fines generation. Without it, we risk the formation of bird nests and accumulation of the fines at raceway boundaries that choke off the gas flow. So by maintaining a high strength active dead man, we ensure the furnace continues to breathe even under these higher thermal and mechanical loads. So now let's look at the specific parameter for this shift. So parameter shift, if we talk about, then we can see that here is the data driven delta for our 15 kg per ton hot metal increase. So we are moving from 160 to 175. So to support this, we are bumping oxygen enrichment by 1.7% and increasing our hot blast temperature to 1165. So the ultimate reward is a significant drop in coke rate from 325 to 312 kg per ton hot metal. So and that's lead us directly to the financial impact. Now, let us talk about the economic impact. And as we can see, that the economics of these projects are compelling based on a calculated replacement ratio of 0.88. We are looking at an immediate 12% saving per ton hot metal. So as we move towards the optimized future state, that potential climb to 18% saving. So by leveraging the market price spread between coal and coke, we are quite literally forging our own cost leadership. So how do we get there? That we have to see, and the timeline is being framed in a very feasible manner. So we can see that the 24-week implementation roadmap, we have a clear disciplined 24-week path to success is given in the slide. So we start with a month-long plant audit, followed by 2 months of infrastructure preparation to upgrade oxygen station and install high turbulence lances. The exciting part of it is the ramping phase, stepwise 5 kg increment with 48 hours stability holds to ensure the furnace is happy with every change. Finally, we will validate the thermal and financial results, and validating these results are pretty more important. So we can say that in conclusion, the excellence in coal injection is our gateway to global steel competitiveness. So by mastering these technical variables, we ensure operational stability and massive cost efficiency. So let's open the floor for our any valuable discussions or valuable suggestions